All right. As I'm watching bowling here, um, I am got my new desk set up and my new office chair. So technically, I am back to normal. Actually, going back to the point of where I left off when I actually moved locations and left everything behind. Which this is probably like the fourth time I've rebuilt my life, and there's no issue there. I see material items as a thing to leave behind whenever I feel like it. The only thing that I do regret was my PC, but have no illusions. You know, might have purchased my first ever PC since 1994 that I have not built myself. In matter of fact, 1994 was my very first PC ever, which I did build myself. And this is the first one that I have purchased out of the store, and Walmart at that, and for $800 price tag from Cyber Power PC, which I've always wanted one regardless, just to try them out because they've always seemed to make good machines, based on reviews and based on the components. And this is no research I did at all. I walked through Walmart. Matter of fact, I went through Best Buy, and I was like, you know what? Let me check Walmart just in case, because I mean, even my last huge 65-inch television that I got, which is a Vizio, that was from Best Buy, but that was between Best Buy and Walmart. And going back and forth, I found one for like $1,100 at Best Buy. Not sure how I missed that at first, but nonetheless, Walmart almost won that battle. So I decided to go by there, and hey, last one on the shelf is just sitting there, $800. I'm like, yo, I can't pass that up. Okay, and now I've upgraded my RAM and my storage, which you already know about, and now I now have my chair that I used to have, and my desk, which is a Veridesk. I still need one more Veridesk, but I'm back in business. So I know it's been a while, and that is because of, like I said, life. Life is one of those things that just always seems to get in the way. Okay, so now let's take a look. We're 3 minutes in, so OSPF. Okay, so OSPF is one of those protocols that is not proprietary. Okay, it's a industry standard. Okay, and I copied this from Google. Okay, I just asked a question about what is OSPF protocol, and this is what came up at the top of the searching. I don't know if it's Google research coming from Google or it's coming from another source. I don't know. Now, OSPF is, which stands for Open Shortest Path First. Okay. Now we didn't talk about what the acronyms for EIGRP was. Okay. In fact, let's go back. Do I have it in there? You figure I would. And no. I think it's enhanced, integrated routing protocol. I think. Let's go back and enhance interior gateway routing protocol. All right, so hey, I can't expect to remember all these acronyms. All right, so now, which I say that as a joke, but it is the reality of you getting into this field. Okay, acronyms galore. Okay, when I learn a new acronym, okay, I always, while I'm reading, I will purposely take that acronym and say the actual words of that acronym. Okay, every time I see that abbreviation in the actual documentation. And that is because that's the only way to get this stuck into your memory. All right. And after a while, you just stop trying to remember, and because you can always look it up. So now, this is a linked state protocol. So remember, let's go back to EIGRP when we were talking about it's a hybrid. It had some linked state attributes, some distant vector attributes. Okay, where a distant vector is the best path is based on hops away, not the links themselves. Okay, where OSPF is based on the state and the information reported about that link. Okay, all right, these links and this information is advertised back and forth, which is called LSAs, link state advertisements. Okay, and every link is sitting in some autonomous system. Now, these autonomous systems, we call them areas. Okay, it is an autonomous system, yes, but it's called an area. So when I actually go and say router OSPF, okay, I'm also going to tell that router what area it is sit in, okay, and every link can be in a different area, okay, or in the same area, or both, okay. It doesn't matter. All right. So we have what is called a backbone area, which is area 0. Meaning that, as you see area 100 in this diagram, area 200, okay, the only way for area 1 to learn about area 2's networks is they both have to be attached to area 0. It must transit through the backbone area. Okay, so if I had put another area over here, all right, can I actually do drawing here? I'm just going to use my mouse here. If I put that didn't work. Wow, okay, so that's funny. Why doesn't the drawing work? Wow. Okay. All right. So you know what? We're gonna do it this way. All right. Let's just copy this. Let's bring in some paint. Okay. So if I had another area over here, okay. And this is 300. I'm sorry, I'm using my mouse here. Okay, so here's the thing. All right. I can set this up, okay, because obviously I'll have to have a router sitting here where one interface will be sitting in area 200, one will be sitting in 300. Okay. All right. This can happen. And my routes, whatever is in area 300, they are there. Okay, but I'm not going to be able to move routes that area 200 has learned from area 100 and the backbone into 300. It's not going to work. Okay, now there's a way of making it work with a virtual link, but still, the concept is you must transit all information through the backbone. So think of a backbone as a tree, okay? The tree trunk is your spine, and your areas are your branches, okay? All right, they're not realistic terms. I'm just using it as an example, okay? So this is very important to understand because, all right, in order for us to have a working OSPF database, because OSPF uses a database just like AIGRP does. Of course, AIGRP's database is called a topology table. All right. We gotta understand that our areas are very important, and every area must set an area 0. Now, I'm not gonna lie. In the 15 years in my experience, regardless of how large this enterprise is that I worked on, okay, and I mean even with multiple data centers, I've only seen area 0 being used for OSPF, okay, all right, and the only purpose of that is to bring in routes from BGP and redistribute them into OSPF, which we never talked about redistribution. So, and that part's okay because we're not going to talk about it today, but that's coming up later on in our lessons. Anyway, so now, our areas, inside every area, there's certain LA or LSA types. Now remember, the LSAs are link state advertisements. Okay? Now, we talked about what an area is and what the backbone area is. Your topology table is going to be a table that is going to list all the routers in the database and what type of routers they are. Now, in the actual, what the router is going to share with another router within that area or in another area is the links that they have and what their states are. And when I mean states, information. Okay? Remember, because this is a link state protocol. The state of the link is what we are focused on. Now, that state of the link is really giving out information so everybody sharing the same database can agree what is the fastest route based on the link information in our database to get to that destination. Okay? So that means in area 0, our backbone router, every router that sits in that backbone or in area 0, okay, it doesn't matter if it's area 200 or 100, I'm just using area 0 as an example, was going to share LSA types, okay, which in this case we'll say LSA type 1, okay, all right, and everybody will agree to that database. Now, okay, if you have a router in a area 0 in another area, that is what's called an area border router. Okay? All right, and let's scroll over here because I seem to be missing some text here. All routers in the area have the same topology table. Okay, all right, so this is important. Okay, so what if a router is in 2 areas? Well, everything in 200, area 200, if there's multiple routers in there, they're going to share their own database. Meaning that in area 0, LSA type 1s are going to go out because all the other areas, all the other routers in area 0 are going to share the database. And 200, okay, in 200, all the routers in 200 are going to have LSA type 1s going through there. Those LSA types are not going to come over to area 0 as LSA type 1s, okay? They might come over as LSA type 3s, okay? But remember, all right, that router, which is an ABR, which is called an area border router, which is pretty much saying, hey, this is the border of, I'm sitting in another area, so I'm a border. I'm a border between area 0 and area 200, okay? So if I need to bring routes over from area 200 over to area 0, I'm going to change that LSA type, okay, into a different type of a different type of LSA. So area 0 knows this is not an LSA that's in our area. It's from a different area, okay? All right, now, our autonomous system border router, and that's kind of funny because wait a minute, isn't the autonomous system 0 and 200 and 100? Yeah, but you gotta understand, you might have different areas within your OSPF, but your entire areas 0, 100, 200 is your autonomous system. Okay? All right? We might have different autonomous systems or different areas in our autonomous system, but the entire thing is an autonomous system. It's our OSPF complete network. Okay? If we are going to go into a different network, like we have over here, where we're going into our RIP network, now we're in not an ABR, because this is not an area border router going into a different area. We're going into a different network. So now we're going into a different autonomous system. So we call this an autonomous system border router. Okay? So now we already have the area 0, or the backbone area. We have areas. We have ABRs. We have ASBRs. Okay? We got LSAs. So our acronyms are already going off the chart right off the bat. Okay? And this is just the basics. All right? So now we got to understand something. We cannot do summarization unless we are doing it on an ASBR or ABR, okay? On an area border router or an autonomous system border router, okay? All right? So, how many routers can be load balanced into OSPF? Okay, I don't know if this is accurate. Since the time that I've actually, from the time that I actually created this documentation, okay, because you gotta understand that all this one that was completely done by me. So that number could be different. This OneNote documentation is years old. So I don't know if OSPF has made changes, but that's a documentation thing that we're not going to look up because I don't really, we don't really have time for it. All right, and really, I don't care. Okay, because the bottom line is that's something that now. Okay, so this is actually a good point, very good point. As an engineer, okay, all right, you come across this information, you might find out that it's 10 or 12. It doesn't really matter. Okay. If you want to use this feature of load balancing, now your engineering mind has to go to work to figure out how you're going to use this in your environment, if it's necessary, or even dive deeper into the documentation. Do you understand how in the beginning, for those who have followed me from the very beginning, in the very beginning, it was always about being very detailed on some of the information, but leaving it open for your own research, but setting it up as a factor like you and I are studying and I'm teaching you as you're looking over my shoulder. Where this time around in 2024 and 2025, okay, the concept is trying to teach you a skill set, okay, and I'm going to tell you the best way I can tell you, okay? And I've had this argument 1,000 times to the point where I don't argue about it anymore because it's just reality. The real learning, the real understanding is at home. It's not at work, okay? All right? Because 9 times out of 10, you're doing work, all right? You don't have time to do these things, okay? Now, there are times where you'll be doing your own research, you'll be doing your own development, you'll be doing your own labs, but I'm going to tell you, okay, this is something that usually isn't part of the statement of work, okay? And you have to, as an engineer, put that in as work, okay? All right? Billing those hours as a means of labeling it as a sense of production, okay? And when I mean production, like you're producing information. Okay? All right? I can't tell you how many times I've had a fight. Okay? And I'm going to tell you the most insulting thing that your manager could ever tell you is, well, if you have to lab this stuff, obviously you don't know the technology like I thought you did. Okay, you know what? I'm not even going to dignify that with an answer. Okay, and never have. But at the same time, it just shows you how people try to diminish your capabilities. Okay, all right. And here's the reality. All right, I don't care who you are. All right, if you ain't labbing your shit, you ain't doing engineering. Sorry, not doing it. Okay, you're gonna act like you are, but you're not. Okay, so if you are putting in a new router, okay, and dude, this is like simple stuff, really. You're putting in a new router, so what do? You take the code that you're going to put on that router and you paste it on that router. This is a new platform, new model number. Okay, all right. You've never had 1900s in your environment at all, or 9000. Never had those. Okay, so you finally get one. So you take all the code that you're going to put on there and you paste it in. First of all, you're going to pay attention to every code to put in there. Did it take it? Okay, all right. You're going to do a diff between that and what's there. All right. What commands did not take? Okay. What returned an error and why? Is it a different command? Has this command been depreciated from this? You don't want to be doing this during your change. Okay. You don't want to be finding this out during that. You want to know beforehand. Okay. All right. This is your labbing aspect. All right. Then what do you do for after that? Okay. A simple data plane test. All right, you do 100 million pings and let it go for a couple, for 24 hours. Come back the next day, see if those pings are still going. Okay, all right, all right. So your data plane seems okay. It's a simple test. Okay, you don't want to put this in production as a core device. And next thing you know, you're dropping packets left and right, and you got interface errors, which you could have realized those if you would have just did a simple lab. Okay, so all right, that enough of that being said. So now, okay, so neighbor relationships. Now, this is playing with the big boys now. Okay, remember I told you that's my favorite message from Disney, playing with the big boys now, because that is this protocol here. There's a lot more things of EIGRP that I could have went into, keychains, authentication, to show you what happens if your router IDs are different, which we never discussed about router IDs. Okay, all right, but with OSPF, this is an important subject. Okay, EIGRP does have router IDs. Okay, if you have two routers in the EIGRP domain with the same router ID, they will not exchange routes. Okay, and you'll have like this weird thing going on, and you don't realize it because you never knew EIGRP had router IDs. Okay, all right, so you open up a attack case, and they eventually find out that you had the same router ID and it had to be changed, right? And you're like, what the hell is that? But still, OSPF is one of those protocols that two things are going to happen, one or the other. One, you're going to go through all the material, all right, and you're going to realize that you're going to have to go over it again and again and again and again and again because there's so much goddamn information. Or two, you're going to quit because you're like, this is ridiculous. Nobody needs to know this much, all right, to be in the network field, okay? And that's, guys, you're in it or you're not. Why do you think this is one of the most hardest fields to get into? Okay, getting in the field, man, that is a milestone in its own, and I'm not kidding. All right, okay, because of all the working parts that is in routing and switching and firewalls. Okay, because remember, this is what I do: routing, switching, firewalls. Okay, so this protocol makes or breaks people. Okay, or makes them quit, or makes them have headaches until they start getting used to all the information. Okay, so now, with that being said, all right, remember the multicast address that AIGRP was talking on. Let's go back up here. .224.0.0.10. OSPF is 224.0.0.9. Okay, and I say that, but let's see if I can find it. No, my bad. Okay, 224. Oh no. Hold on. I might have to look it up. Okay. All right, you know what? Let's do this. Oh my God. I was completely wrong. Okay. All right, my bad. Okay. All right. So my documentation is right here. Okay, but we'll get to that later on. It's 224.00.5.6. All right, we'll discuss that later though. But now, oh, and by the way, you see how many times I've been wrong since I've been doing this? As far as doing the lessons again in 2024-25, get used to it. All right, it's just gonna be part of your DNA being wrong. So, but nonetheless, it's just too much information. So, but. You'd be surprised what you can remember and what you can't. What needs to match to form a relationship? Now remember, with EIGRP, we created a direct point-to-point link EIGRP adjacency, or a relationship. Okay? Hang on a second. Alright, before we exchange routes, OSPF is the same. We need to create an adjacency. Now, EIGRP is a Cisco proprietary protocol. Now, several years ago, okay, which probably was more than that, okay, I had read a Cisco documentation stating that they were going to release EIGRP as an industry standard. Now, to this day, I don't know if other platforms have picked that up or if there's RFCs written on that standard, which I'm pretty sure there is from what I remember, but I'm not sure, okay? Nonetheless, at this point, think of EIGRP as a Cisco proprietary device, meaning that you got to have all Cisco devices to run EIGRP. Okay, unless Juniper or Brocade or whatever has actually integrated that as a standard, and Cisco has successfully created an industry standard following the rules of IEEE to actually create that documentation. Not sure. So, in OSPF, we have hello timers. That means every so many seconds, I'm going to say hello, 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 okay? And those hello messages are sent out expecting a response in order for an adjacency to be formed, okay? Our dead timer. Now, a dead timer is the opposite of a hello timer for the concept of if I do not get a response after 3 hellos, the fourth interval, or how many seconds it is, I'm considering it dead. Okay? Alright? So, to keep that adjacency up and running, my hello messages need to be responded to. Okay? Our area ID, that means when we configure OSPF, like I said, router OSPF, area 0, okay, both of those routers need to be in the same area. If they're not going to form an adjacency. Authentication, if you're using a password, okay, that's important. Network mask. Now, that's something I did not discuss in EIGRP. Okay, if you're not on the same network as EIGRP or OSPF, you're not going to form an adjacency. Okay, now, OSPF, though, to make it even more daunting, okay, has network types. Okay, notice that my next section under neighbor relationships is network types. Okay, that's a whole discussion of itself. MTU. Now, this is an important one. Okay, the last time I had an MTU issue was between a Juniper and a Cisco device. Okay, all right, and the engineer could not figure out for the life of him what it was. Okay, all right. Now, I asked him to check the MTU, and he was like, "Yeah, the difference." I'm like, "You're not going to form it." I said, "You're going to have to make a change to change the MTU of that link, not the." I said, not the actual layer 2 MTU, the IP MTU. They need to be the same. Okay, all right. Very important information, and that engineer did not know the difference, so I had to explain that. And once that was done, his adjacencies came right up. Okay, your stub flags. Now, stub areas. Okay, those are another discussion. Okay, so your stub flags, meaning that if I am a stub router, okay, and what a stub router means, there is no other routers past me. Okay, that this is it. Okay. That's it. We're not going in. We're a stub area, okay? So, and a separate router IDs, meaning that same router IDs. Not only are you going to not exchange routes, but you're not going to form adjacencies, okay? So with OSPF, there are so many things that I could set up to cause you havoc of creating adjacencies. And there's so many things that I can do to make you troubleshoot and kind of have a bad day on trying to figure out why the adjacencies won't pop up. Okay? All right? And if you have to actually try to resolve this in 30 seconds, well, now you can see the aggravation that I can put upon you. Okay? Now, some of our network types, okay, are broadcast, point-to-point, non-broadcast networks, okay? Now, our hello timers by default are different in these network types, meaning that if I set a network type to broadcast, okay, what does that mean? Now, you got to understand, okay, that these are a per link scenario, okay, meaning that I have to go underneath the actual link to actually change the network type. And you know what's funny? Let's kill that for a second, because hold on, I'm getting a brain cramp here. So by default, your timers for broadcast and point-to-point networks, okay, is 10 seconds. For non-broadcast networks, there's 30 seconds. Okay, so that means on a broadcast and a point-to-point network type, the hello messages are fine. Okay, all right, but you gotta understand that these are default values. All right, I will be able to change my hello timer specifically to what I want by doing manual configuration. Okay, now, what is a non-broadcast? We're gonna leave that alone. Okay. Well, let's. Bottom line is, it states this: no broadcast traffic is allowed. Okay, meaning that in a non-broadcast environment, 9 times out of 10, I have to have manual configurations on what the destination is going to be, because I can't use broadcast messages to find out where things are. Okay? Alright? That means multicast, which multicast traffic is kind of a broadcast traffic, so I can't even use multicast traffic. I have to manually configure what my neighbors are going to be. Does that make sense? Alright? That means I can't use multicast, which is a broadcast message, for them to communicate on. Because once I enable OSPF, I'm communicating on the multicast address. That means once I enable that interface, first of all, I'm listening on the broadcast on that broadcast address, and I'm also sitting on that broadcast. So that means whoever's a member of listening on that multicast, I said broadcast, but multicast address, is going to receive my message, because we're talking on the same channel, so to speak. Okay? Alright? So, what is in a hello packet? Well, look at all that stuff. Router ID, hello and dead timers, area ID, priorities, passwords, if enabled, subnet mask, and DR and BDR addresses. Okay? And we already talked about what a passive interface is. Now, remember, every router is an individual. Okay? An individual entity, meaning that in order for me to have all these criterias to form an adjacency, it has to be sent to the other router in order to compare with what it has before an adjacency is allowed, which is going to be in the hello packet. Does that make sense? Okay? Alright? And now, network types. Broadcast. That means I can send multicast, all 255s, 255 to 255 to 255 addresses, all across the board. So I'm good in a broadcast network type. Now, this is a network type. Okay? And you gotta understand that when you configure this, you determine what type of traffic you are going to allow or not allow. Non-broadcast. Well, like I said, if I'm doing non-broadcast, there is no communicating on the multicast addresses. So I need to go in there and literally say my neighbor of my OSPF is 1.1.1.1 in order for it to send a unicast hello message to that actual device. It doesn't matter that it's point to point. Okay? I had to manually specify that. Okay? Point to multi-point means that I have router 1 and it's connected to router 2 and to router 3. Alright? That allows me to have multiple adjacencies on that main router. Okay? Point to point is exactly what it means. Okay? Point to multi-point non-broadcast. Same concept. Okay? Yes, these are real terms. Yes, these are the crucial aspects of OSPF. No, you cannot avoid this information. Okay? You're playing with the big boys now. Okay? We're going to leave this as it is, and be strong, be determined, be Cisco, and we will continue on with the next video, with the next lessons. See you guys later.